Hello and welcome to Sudoku. Here is a product sandwich Sudoku which was created by Madmahogany for the Sudoku Mahabharat round 4, which was dedicated to math variant. And this one was very mathematicky or something like that. So the concept is that whenever you have a clue in the margin, this clue is the product of all digits sandwiched between 9 and 1 in the corresponding row or column. For example, you could have a 1 here with 8 and 3, and this would work to have this product 24. This was the highest pointer in the tournament, but I think it was not the hardest by far, and I thought that it was even the easiest of all 5 variants, but that's personal opinion, and this has no bearing at all. And actually, the main point is that it was a very good puzzle, as the whole round was. Okay, so where do we start? We start with this, I think. I start by highlighting 1s and 9s, actually. Those are the sandwich crusts. So then this is a very high clue, and something to note is that the product of all digits from 2 to 8 gave a result of 40,320, also known as the factorial of 8. And this is, this big number divided by 6. So we know that outside the sandwich, we have a product of 6, which will be either the single digit 6 or 2 and 3. But because of this given 3, this is not possible. It has to be an isolated 6. So what are the options? The options are that there is 1 or 9 here, 1 or 9 here, and a 6 there. That's the first option. And the other one is that the crusts of the sandwich are here and 6 is here. So we know that there's 1 crust here, 1 crust there, and 6 here or 6 there. That's the first thing. The second thing that draws my attention is this 42 clue and this 7, because the product that gives 42 will include the 7. So there has to be a crust here. There's a 1 here, and the corresponding 9 must be somewhere here, either with a 6 here, which would go with a 4, or with 2 and 3 here and the 9 there. Now, something of interest is all those small numbers, because we now know that this 4 is the only one in the sandwich, so 4 has to be here or there. So we get one option, which is 4 here with a 9 there, or 4 here with the 9 there, which would be convenient, because with 9 here we get the 1 here, the 6 there. That would be easy to handle. But if 9 is here, then we get a 2 here and a 1 there. And that seems to work. With a 1 there, we can have 4 and 6 here, for example. So nothing definitive here. What's more interesting, I'd say, is that all those are 1-digit sandwiches. And how do we get those to work? Well, obviously we need to have somewhere something like 149 or 941. Somewhere we must have 139 or 931, and somewhere 129. And how do we do that without 1s and 9s conflicting? Well, I think that we must have one of those here, maybe 149 here, 139 here, 129 there, but they must be all included in some box. Because if we don't, let's imagine we make a sandwich here with a 4, with a sandwich here, then let's say 3 is the next one. Then we can only put one end of the sandwich in here and the other end here. And then for the 2 we must put an end here and an end there, and it won't work. So the only way of having them do their thing without conflict is to have each one of those sequences in the same box. And one thing important to note is that 139 can't go here. Because if I put, let's say, like this, then this 3 must also be in this sandwich. So it won't work. I should have another 1 9 pair here. So that won't work. And that won't work with 4 either. If I try to put 9 4 1, then because of this I need to put a 4 here as well. So now I know that the sandwich in this box must be the one with the 2. So this way. And it puts this 4 here. And now I know that for this sandwich, 6 is out here, and we get the 1 9 pair there. And this one is resolved, this one as well, this one as well. And now because of this sandwich is here, with a 3 here and the other end there. And now this 24 is here. It can't be 4 times 6, so it has to be 8 times 3. And because of this 8, we get an 8 here, a 3 there. There's a 2 here by Sudoku, and 5 and 6 in those cells. Okay, so that's a lot to begin with. Where do we look now? This 24 has been found. Where's the next interesting part? Oh, this 42 now, we need another 2 before placing the 9. 96. How do we make 96? Well, obviously, it won't be the product of 2 digits, because the most we can make is 8 times 7, which is 56. So we need all 3 digits, and the corresponding one will either be here or there. But here it wouldn't work. As we said, we must have those 3 cells or those 3 cells to make the sandwich. So one won't go there, one will be here, and now we know that this sandwich is this way around. And we get a 9 down there. We get a 9 here. And there's a 1 down there. And because the product is 8, the sandwich must have 1 or 2 digits inside. And here it would put the 9 there. Here it will put the 9 here or there. Because of this 9, the 9 will be here in any case. But I don't know yet whether it's 2, 4 or just the 8. Now this 6 must use a 9 here or there. And the 1 must be down there. So this disambiguates. 1 is here, so there's this 8. And for this 48, we need 2 and 3 this way. So now there must be a 9 somewhere in one of those cells together with a 1. And we know that 3 is not available, so it will be with the 4. And we get this sandwich here, and because of this 9, it's 1 here, 3 there, and 9 here. We get a 1 here. And do we have all 1s and 9s? I think we do. Those now are resolved. For this 6, we need 2 and 3. And for this 96, we must find a product. We must find the correct product here. So what will it be? One option, 8 times 12. But you see that this one is not available because of this 3, and those ones for that matter. Actually, by Sudoku, we get a 3 here. Is there any way of doing that? If I don't use 8, 6 times 16, that's the same decompositions. Now that's the only way. 8 times 2 times 6, so that's 8, that's 6, that's 2. And now this is just standard Sudoku. 4 and 5 here, there's a 4. This is a 6, this is a 5. And down there I get a 2. Here 7 and 4. That's a 2. That's 7 and 6. Because of this, there's a 3. No. That's 4 and 5. Stop being a canard. Those are 4 and 7. Here 8 and 4. There's a 4. That's an 8, that's a 6. 5 and 3. There's a 3 here. 7 and 6. This 5 gives this, and that's 2 and 7. Up there 5 and 8. Here we get a 6. 5, 7 and 6. 5, 7 and 6. And that's a 5. We get a 5 here and an 8 together with 7 and 6. That's it. And we end with 4, 3, and 7, and it works. And of the 5 videos that I've done in this series, this one is the shortest. It is really. So that seems to be the less difficult one, but it really had this funny stuff about those configurations, those sandwiches that must be disjoint, really disjoint in those 3 columns. That and this logic. Maybe the logic in itself was tricky. I just found that it needed less work than, say, the Mathrax did, for example. Well, thanks for watching this video. Thanks to Madhav for all these very good puzzles. And see you soon on Sudoku.